So our next speaker is Damien François, and he's going to tell us about the HPC cluster they have at UCLouvain, which was my university, by the way. So,
Thank you. So, hi, I'm Damien, as we just said. I'm a HPC systems engineer with the Université Catholique de Louvain. I work in the Center for High Performance Computing and Mass Storage. So I'm located in Louvain here. So you are here, and I'm here. Well, actually, at the moment I'm here, but you know what I mean. Just to show you a bit about one of our clusters, small cluster. So if you're wondering if it's in the top 500, it is not. Don't bother looking. It's a cluster that has grown organically. From the beginning, it started with as low as a few as 20 or 30 nodes, and it kept gradually growing as more scientists came to us with money. We bought some hardware and we added to this cluster. So it's a bit different from the other clusters we have, which we buy as a whole. So we buy a whole cluster and it comes with a full stack for provisioning the cluster, running the cluster, and so on. So here we had to build everything from scratch. And we actually started manually. With every information was in our heads, and so we added some nodes, and we were thinking like, okay, what do I need to do to add this node to the cluster? And everyone would bring some information from their heads, and then we started thinking it's better to have that written somewhere. So we started writing documentation. And then we gradually improved towards automation. We made the documentation actionable through scripts, and then we read books about DevOps and books about infrastructure as code, and we decided to use configuration management systems to manage the whole things. So we had a look at what tools were available, and we settled on 3 tools. One of them is Cobbler, the other one is Ansible, and the third one is SaltStack. So I know that often Ansible and SaltStack are seen as distinct alternatives. You either choose Ansible or Salt, and if you discuss with people, you just start wars by saying that this one is better than this other one. The thing here, we believe they work nicely together, so it's something I would like to show you during this talk, is that Ansible and Salt, they work together pretty nicely. So to show you that, I will just go through the journey of a new node that must be added to our cluster. Once we have unboxed it, we need to put it in the racks to label the machines, to label the cables. We need to choose the name, an IP. We need to gather the MAC addresses, and then we enter all the information into Cobbler, and Cobbler will take care of installing the operating system. And then there is another stage where we integrate our node into the infrastructure, and that is where we use the Ansible. And then the third stage is the configuration, where every software, non-user software that has to be installed is installed, and where the configuration files are propagated. And then after that, it's ready for job. So I will spend a bit more time on each of the steps. I don't know how many of you know about Cobbler. So it's a tool that, well, the advertising is that it's a tool for deploying machines. So basically, it's a wrapper for the PXE, TFTP, DHCP servers, and it allows you to manage operating system images and machine profiles. So we use it to install the operating system, most of the case sent to us in our case. We use it also to set up hardware-specific configurations, so for the disk partitioning or for the IPMI. And also it's used to set up the minimal configuration that we need for the other tools to work. So Ansible needs the SSH keys, and we also use a lot of SSH ourselves during maintenance and so on. So we deploy SSH keys, and we install the Salt minion, which is the agent for the SaltStack software that runs on the machines. When the node is deployed, so the operating system is up, we use Ansible to integrate it in our infrastructure. So I see Ansible as a shell script on steroids with built-in features such as safety, idempotence, and a lot of APIs that are available. We use it for one-off operations. For instance, we are using Zabbix to monitor the whole infrastructure. So when we add a new node in the Manneback cluster, the Ansible playbook takes care of registering the node to Zabbix so that we have all the alerts and so on that are activated for that node. We also use an inventory system named GLPI. It's a gestion libre de parc informatique. It's a software that we use to keep a list of all the compute nodes and all the other machines we have bought. And it holds our hardware issues and tickets and so on. And so when we have a new node, we need it to appear in the inventory, and that is done through the Ansible playbook. And we also use the Ansible playbook to register the node to Salt. So I said that the cobbler system would install the Salt agent, and then the Salt agent will talk to the Salt master and say, okay, please allow me to register to you, and this allow step is taken care of by the Ansible playbook. We also use the Ansible playbook in a way which might be a bit unusual. We use it to build the configuration files. So it's a cluster, a compute cluster, so we have a job manager, which in our case is Slurm. And then the Slurm needs to know what features are available from which compute nodes. So in the slurm.conf file, we need to have a line for each of the compute nodes saying that it has that many cores, that it has that amount of memory, and so on. And so we use the Ansible facts and other feature gathered by the Ansible playbook to build that slurm.conf file. The slurm.conf file is not propagated to all the compute nodes by Ansible, but Ansible builds the file, and we do the same, for instance, with the etc host for DNS mask server, or this file for SSH for non-host for host-based SSH. Once those files are created, we then use SourceStack as a central configuration management server. So basically, Ansible will create the configuration file, and the Salt will propagate all the configuration file, and it will also install the software that we need. So not the software for the users, for that we use EasyBuild, of course. But for the other software, they are installed with Salt, and it's used to mount the proper file system and so on. So we have 3 steps. Deploying the operating system, integrating the node into our infrastructure, and then configuring the nodes and installing the software. Once that is done, we still need to check if we have a new CPU architecture, in which case we need to recompile every other software so that the users find the same set of software on all CPU architectures. And also another step we need to take is that if the machine was bought by some specific group, and that group needs access to that machine with a specific quality of service, we need to integrate that into the Slurm system, and that is done by a tool which we have developed, and I will be talking a bit about more later, which is called Sluffle, but then it's ready for jobs. But more generally, we believe that those 3 tools can be used in context more general than simply the HPC cluster. And we've also used it by simply replacing Cobbler in this step with OpenStack or with Vagrant. It all works, the chain works, because typically when we develop stuff or when we test new stuff on our laptops, we use Vagrant and VirtualBox, and then we use Ansible to install a temporary cluster in VirtualBox and so on. But we don't care about the configuration management system. I don't want my VirtualBox machines to appear in the central Zabbix system or in the monitoring system. That is by contrast with the or staging mini clusters. So we have a small cluster that we use to test stuff on. We do not deploy the operating system at every time we try something, but we like to keep the configuration in the configuration management system. And so the next thing is that whatever development stage or production step we are in, the set of playbooks that we use here is the same. And the Salt server, so the server for the configuration management system here, is the same whether we are in production or in the stage. So it allows us to really test the stuff we do either in the VirtualBox machines or on the small cluster. And if we know that it works here and here, the same playbooks work here, we know that they will work here. And it's a way to test stuff. So there are some features that overlap between Cobbler, Salt, Ansible. For instance, installing a package can be done in either steps, but we have a simple recipe actually. If the software is specific to the development, for instance, the VirtualBox guest additions is very specific to the development stage, we install it in the vagrant provision step. For everything that is related to hardware, such as the drivers, we install it in the Cobbler, in the kickstart of the Cobbler system. When some piece of software is useful both in the production area and in a stage area, for instance, the Zebex agents, so the piece of software that monitors the health of the system and so on, then we use Salt to install it. And if some piece of software is needed in all three stages, then we use Ansible. For instance, Slurm, the job scheduler, I need to install it, of course, in the production machine, but I also need often to install it on the test cluster because I want to test some feature or to test a new version. Or I want also to be able to test it in virtual clusters in my laptop to do stuff where I can break everything and nobody notice. There are some gotchas, though, of using Salt and Ansible at the same time in your head. It can be confusing because, for instance, when you want to upload a file in Ansible and Salt, Ansible expects the keywords that is RC, so the short for source, but Salt requires the full word source. And it can be confusing, especially considering the fact that for installing a package, it's the opposite. So Ansible expects the full word package, while Salt prefers the shorter one, PKG. Nevertheless, we love both of them, not always for the same reasons. What we love about both is that they are both Python, they are both based on YAML, and they are both using Jinja for templating. We love the fact that they are shipped with a lot of modules, which are very interesting. We like the fact that Salt is our single source of truth. So we have a Salt server somewhere in our architecture, which is syndicated, as Salt people call it, on our main clusters. And so in one machine, we have the configuration of every single computer in our infrastructure. We also have the history of the jobs which were, so the configuration changes which were run through the Salt server, so we can trace what happened and so on. We like the fact that Salt is highly scalable, so with one server in a small virtual machine in our OpenStack, we can handle the 300 or 400 machines that we have in the data center. The fact that it offers a second entry point is also interesting because when you accidentally kill all your SSH servers on the compute nodes, you are very happy to have Salt on hand to be able to restore the servers. By contrast, we like the fact that Ansible is very simple to grasp and very simple to build. So an Ansible playbook is very easy to read, even for people who do not know Ansible beforehand. So it's easy to share. If I build some Ansible playbook to do something, I can easily share it with people from other universities and are able to use it without having to replicate the whole infrastructure. Just the playbook is rather self-contained. The fact that we've also often used Ansible to fix stuff. When you start playing with Salt, sometimes, because Salt is so powerful, you do a little mistake and you break everything on your cluster. I found it very easy to fix things with Ansible. It's much easier than with Salt to repair what was done and then correct the configuration in Salt. We love Ansible so much that when we had to write some piece of software to connect our LDAP system to SSH or Slurm, for instance, when a user registers to our system, they use SSH public keys, which are stored in our LDAP system, and we need a way to provide them to let SSH know that the public keys are in the LDAP system. So there are connectors that exist right now, but when we started the project, nothing was mature yet. So we developed a piece of software also to register users from the LDAP to Slurm and to create several file systems. So when a user appears, we need to create its home directory. In the home file system, we need to have a directory for the user on the Scratch file system and so on. So we developed a tool named Sluffle that basically monitors the LDAP system and then triggers playbooks when things change in the LDAP. So it just making the link between the information that is in the LDAP. When it changes, then playbooks that are written by the system administrators I run, and the information from the playbook is pushed, from LDAP is made available for the playbook. We also played a bit with Salt, and for instance, we developed custom grains, which we can share with you, which allow us to actually, in the Salt top file, have specific rules depending on whether a machine is in the Slurm partition or in other. So in Slurm terminology, a partition is the equivalent of a queue in SGE or PBS. So here you see that two rules that say that, okay, if the node belongs to the Zoe partition, then we need this state to be active as well. So my main message here was that Ansible and Salt, they work very well together because first, I see them as complementary, and they use the same building blocks. It's all Python, Jinja, YAML, and so on. And if you add Cobbler to the team, you have a nice trilogy of tools that allow managing a small Tier 2 software. And they all integrate very nicely into our full stack. So we are using all of this software in our system. One which I like a lot, which is SSH Shuttle. I don't know if you know it, but it's SSH-based VPN-like software. Very easy to set up and very easy when you are a sysadmin on the go and you are in the hotel room or at home. Just run it and you feel like home. So if you want to know more about this, you can visit our website where we have a small page behind the scenes where basically we list every software that we use, every open source software that we use, and we explain how we use it. So thank you for your attention. Yes?
Do you also take care of people being no longer upgraded? Do you remove users from the stream, or is it appended?
So we never
Can you
remove...
please repeat the question, please?
Yeah. So the question is, do we kill people, basically? Yeah. Okay. So we do not. So someone who entered the LDAP system will always stay in the LDAP system, but login and accounts expire. And actually, in our system, we require all the user to renew their account every year. So if a user does not renew their account after 1 year, the account is marked as expired. And so there's a shadow expire field in the LDAP, so the user is not able to connect anymore. But we keep the history. It's something we are thinking about, especially in the context of the GDPR. So we need to think about maybe we will anonymize that information or delete it in some way. But we often have researchers that stay for 4 years, then they go away for 4 years, and they come back 4 years later, and they expect to retrieve the same data as before. And so we keep the data and we keep the login for a long time.
Yes.
One of the problems we have is in Werewolf, the configuration is propagated through all the nodes in the cluster. So we don't need the salt to do all that for us. The problem is, if you have like thousands of nodes, then copying every time the configuration changes and you have to copy to all the nodes at the same time, you like overload the bandwidth. And so what Werewolf does, it kind of randomizes, but then you don't know when you actually copy it to when each node have the new configuration or not. Do you have that problem? If you do, how do you solve it?
So the question is, when you have a very large cluster, which we do not, so copying a file to a large number of nodes can take a lot of bandwidth, and sometimes you can encounter issues with the network. So Salt was made specifically to be highly scalable. So basically it's written around a messaging queue. So some people say that Salt is actually an event-based system, which can be also used for configuration management. Just like I've heard people say that Emacs was a Lisp interpreter that can also be used as a text editor. The nice thing about Salt in that respect is that you can ask for every job where it's in so you can use Salt run list jobs, and then for every node you know whether the configuration was already deployed or not. So you can see the state of every node at every moment. We have 200 nodes maybe, so we don't have the issue actually.
Any more questions?
Do you know how the complex software, how would it compare to something like ROX cluster?
So how does Cobbler compare with the ROX cluster? Cobbler is has a much smaller scope. So Cobbler, it just wrappers around the DHCP server, TFTP server, and Pixie server. So it's used outside the HPC context, basically. So there are not a lot of features, and we basically use the basic features. While I believe ROX is a much more ecosystem, which allows also to deploy the full operating system, full cluster, sorry. But here it will just let you deploy the operating system, and then it will say, okay, the other is not my job.
Further questions? No? Okay, let's thank our speaker.